Our task is to determine whether the following series is convergent or divergent. The summation from 1 to infinity of sine 1 over n. After analyzing the series, we recognize a similar series, the summation from 1 to infinity of 1 over n. After figuring out the convergence or divergence of the simpler series, we can use the limit comparison test to figure out the convergence or divergence of the summation from 1 to infinity of sine of 1 over n. This simpler series is one that we recognize. N is raised to the power p of 1. The p-series test states that if p is less than or equal to 1, the series diverges. Let's review the limit comparison test. The limit comparison test states that if the summation of a of n and the summation of b of n are both series with positive terms, and the limit as n approaches infinity of the ratio of a of n and b of n is a value that is finite and greater than 0, then the two series will either both converge or they will both diverge. Let's check the conditions of the limit comparison test. The terms of both series, the sine of 1 over n and 1 over n, will always remain positive. Thus, we have successfully checked the conditions. Now, let's perform the test. We first set up the limit. The limit, as n approaches infinity, of sine of 1 over n over 1 over n. Because the ratio is indeterminate if we plug in 0, we will use L'Hopital's rule to evaluate the limit. To do so, we take the derivative of the numerator and the derivative of the denominator. We can use the chain rule to figure out the derivative of the numerator, sine of 1 over n. That evaluates to negative 1 over n squared, which is the derivative of the inner function, times the cosine of 1 over n, the derivative of the outer function. We can figure out the derivative of the denominator by simply using the power rule. That evaluates to negative 1 over n squared. We simplify and cancel out, and we are left with the limit as n approaches infinity of cosine 1 over n. If we plug in infinity, it evaluates to the cosine of 1 over infinity, which equals the cosine of 0, which equals 1. 1 is finite, and it is greater than 0. Thus, according to the limit comparison test, we know that both series will diverge. And that is our final answer.